Hello students. So one last example related to this property. Let us solve in this video. Evaluate integral 0 to pi by 2 1 upon 1 plus cot x dx. So as usual, let us consider I. Let I is equal to integral 0 to pi by 2 1 upon 1 plus cot x dx. So how to identify this integral for this property? See, in the numerator 1 is there, same term is also present in the denominator 1, and also the lower limit of this integral is 0, so it must be 0 to apply this property. Let us start. First of all, what is the trigonometric ratio of cot x? So in trigonometry, cot x is ratio of cos x and sin x. Cot x is equal to cos x upon sin x. So apply this formula here. I is equal to integral 0 to pi by 2 1 upon 1 plus, in place of cot x we'll put cos x upon sin x dx. Now take LCM of these two terms. I is equal to integral 0 to pi by 2 1 upon sin x into 1 is sin x plus cos x upon sin x dx. This sin x will go in the numerator, so you will get I is equal to integral 0 to pi by 2 sin x upon sin x plus cos x. Now let us consider this as equation number 1. In equation number 1, in this integral, now we will apply this property. So applying property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So what you have, first of all, let me compare the value of a with the given integral. Here value of a is pi by 2. So how you can apply this property? In place of x, here, here and here, you have to put a minus x. So here, since the value of a is pi by 2, we'll substitute in place of x pi by 2 minus x, pi by 2 minus x, and pi by 2 minus x in place of x within brackets. Don't forget to put brackets. So I is equal to integral 0 to pi by 2 sine, within bracket, in place of x, a minus x. Since the value of a here is pi by 2, so you have to write pi by 2 minus x. In the denominator, sine, in place of x, pi by 2 minus x plus cos pi by 2 minus x dx. Now again in trigonometry, the value of sine pi by 2 minus x is cos x, and cos pi by 2 minus x is sin x. So here and here we'll put the value of sine pi by 2 minus x as cos x, and here in place of cos pi by 2 minus x we'll put sin x in the next step. So I is equal to integral 0 to pi by 2, you will get cos x upon cos x plus sin x dx. Now consider this as equation number 2. So next step is, after getting equation 2, add equation 1 and 2. So adding equation 1 and equation 2. So let us add. How can I add this? In both the equations, in the LHS, I is there, so I plus I. Integral is common, so take integral 0 to pi by 2. In the equation number 1, the RHS, the fraction is sin x upon sin x plus cos x. See here. And in the equation number 2, integral 0 to pi by 2. Fraction is cos x upon cos x plus sin x dx. I plus I is 2i. 2i is equal to integral 0 to pi by 2. Since the integral limits are same, you can take common. Both the fractions denominator is same, sin x plus cos x, sin x plus cos x. So here also on taking LCM you will get sin x plus cos x, and in numerator add both the terms, sin x plus cos x. So as usual, on adding equation 1 and 2 you will get both the numerator and denominator same value, cancel both the values, you will get 1. So 2y is equal to integral 0 to pi by 2 1 dx. Integration of 1 is x, so integration of x1 is x, limit 0 to pi by 2, and put the values of limits in place of x. First put upper limit, that is pi by 2, then minus sign, put lower limit 0, so that is pi by 2. So final answer is I is equal to pi by 2. This 2 will be coming here, 2 into 2 is 4. Answer is pi by 2, pi upon 4. This is the final value of the integral.